Hello students, now in this video we have to see the Karl-Pearson correlation coefficient of skewness. Now already we have seen the definition of it. What I say? Karl-Pearson's coefficient of skewness. We have to measure the skewness. For that we are learning these coefficients now. Now this is given by the British biometrician and the statistician Karl Pearson. You know it is also known as Pearsonian coefficient of skewness. Now we had already seen the definition of it. It is given by him. It is given by this coefficient of skewness by P for Pearson. It is given by him as a difference of mean and the mode, and take the ratio of that difference with standard deviation. That ratio is nothing but this Pearson's coefficient of skewness. Now here there is no limit to this measure in theory. It is a slight drawback of it, but in practice the value of this coefficient of skewness given by Pearson is rarely very high. Usually it lies between +1 and -1. In case of mode is ill-defined, we use the empirical relation for moderately skewed distribution. Sometimes if we are unable to determine the mode, that time we are using the empirical relation, where the averages between the mean averages have the following relationship. What the relationship for empirical relationship is? What? The mean minus mode is equivalent to what? 3 times mean minus median. So as this relation with us, that's why this Karl-Pearson coefficient of skewness can be written as 3 times mean minus median, and take the ratio of this one with standard deviation, sigma. This is also the formula for that one. Now as I say, some of the properties it has, as its value, most probably its value lies between what? +1 and -1. Such a things, let us see the properties, or we can say in other one, interpretation of this formula. What does it gives? Interpretation of it. So the first one, its value usually lies between +1 and -1. Okay. Then second, when its value is 0, the distribution is symmetric. The distribution is symmetric. Okay. If its value is 0, the distribution is symmetric. Fine. Then third, when its value is negative, the distribution is negatively skewed. It's very easy to remember. The distribution is negatively skewed. Fourth, for positive also we can write, when its value is positive, the distribution is positively skewed. positively skewed. Now what about this 0? Look at here. Its value will be 0 only when this numerator will be 0. When the numerator will be 0, if mean equal to what? Mode. And mean, mode and median are equivalent, that time the distribution is what? Symmetric. And these two cases for non-symmetric or asymmetric, we can say. So if the ratio is negative, it will happen if mode is maximum than the mean, fine, and if it will be positive, then mean will be more than the mode, fine. So that time it will be positive or negative. Standard deviation is always positive because it is a positive square root of variance, fine. So remember these things. It may be 0, it may be negative, it may be positive, this ratio. So according to that, it will be symmetric, negatively skewed or positively skewed respectively, fine. This is about the theoretical part of Karl Pearson's coefficient of skewness. Now let us see the examples on this. So let me take the first example. Suppose example 1, mode is larger than mean by 4.5 and the variance is 121. Compute coefficient of skewness. Compute coefficient of skewness. Okay. So solution for that. Now given to us first that mode is larger than mean. Mode is what? Larger than mean by 4.5. So means what? That is what? Mode is denoted by MO. It will be what? More. Means when mean is calculated, if we add 4.5 in that one, then we get a mode. It is what? X bar plus 4.5. This is the meaning of it. Fine. Now second thing is given to us, that is what? Variance. What is variance? Variance nothing but square of standard deviation. It is what? 121. Therefore sigma is what? 11. Fine. Now we have to determine coefficient of skewness. Therefore coefficient of skewness is what? Mean minus mode upon what? Standard deviation. Upon standard deviation. Fine. Now what is mean minus mode? Look at here. This is mode is equal to x bar plus 4.5. So let me shift this 4.5 to this side and mode to this side. It can be written as x bar minus mode is equal to what? Minus 4.5. As such we can write this equation. Fine. So what can we write here? Mean minus mode will be what? Minus 4.5. The difference between them. As mean is less, mode is bigger, that's why the ratio is what? The difference is negative. Upon standard deviation is 11. So this is what? Minus 0.4091. This is the value of what? Coefficient of skewness. Pearson's coefficient of skewness is minus 0.4091 here. Fine. But suppose it is asked that how does this skewness. So the value is what? Negative. So we can say in that case the distribution is negatively skewed. We can say about the distribution, nature of the distribution. That time we will say it is negatively skewed as the ratio is negative. Fine. If it is asked in a question, or if it is not asked, still you can write it in extra. Fine. Now the next question, similar kind of second question, let me take it very soon. Mode is larger than mean by 5, and variance is again 121. The question is that compute coefficient of skewness. Okay, so now again the same thing is here. Solution. What is given to us? Mode is equal to what? Mean plus 5. So this gives mean minus mode is equal to what? Minus 5. First thing. Second thing, variance. Variance means what? Sigma square, that is equal to what? 121. So this gives sigma is equal to what? 11. Therefore, coefficient of skewness, Pearson's coefficient of skewness is what? Mean minus mode upon what? Standard deviation. So it will be minus 5 by 11. So it is minus 0.45. Fine. Now the next one, next example. Suppose given that arithmetic mean equal to 225, mode equal to 213, and variance is 164. The question is that calculate Karl Pearson's coefficient of skewness. And comment on the nature of distribution. So, solution. Now you know the Karl Pearson coefficient of skewness is what? SKP. It is what? Mean minus mode upon what? Standard deviation. Let me write it completely. It will be standard. Okay, standard deviation. Fine. So now we have the value of mean. It is what? 225. Minus mode is 213. And you know standard deviation is nothing but what? Square root of this variance. So 164 square root. Since variance is what? 164. Fine. Now let us simplify it. It will be what? 0.93704. It is greater than 0. So what can we say? The nature of distribution is what? Positively skewed. So we can say distribution is, from this, distribution is what? Distribution is positively skewed. positively skewed. Okay, this is about the solution here. Now let us take some more. Now next example, suppose for a distribution of weights of 100 students. Mean and mode are 45 kg and 49 kgs respectively. Okay. If the value of Pearson's coefficient of skewness is minus 0.4, find the value of coefficient of variation. And median. These are the question. Fine. Now solution of this. Look at it. What is given to us? First of all, the distribution of weights of 100 students. So n is equal to how much? 100 meters. Now mean and mode are given. So mean is what? 45 kg and mode is what? 49 respectively it is. So first one will be mean, second one will be mode. So mean means what? X bar. X bar is what? 45 kgs and mode. So mode is how much? 49 kgs. Okay. Now what is given one? If the value of Pearson's coefficient of skewness means what? Skewness. Coefficient of skewness is how much? 0.4, minus 0.4. Okay. What is asked to find? What we have to find? We have to find coefficient of variation means CV first, and second one we have to find median. So median is how much? These are our questions. So now to find out coefficient of variation we need standard deviation and mean. So from the we have mean, we have to find this coefficient of skewness with us. So from that we can determine the standard deviation. So also we have to find median. So we have the empirical relation between mean, mode and median. So we can, from that we can determine easily the median of it. So let us find out first the coefficient of variation, later on let us go for the median. Okay. So now this coefficient of skewness is what? Mean minus mode upon standard deviation. So it gives us standard deviation, that is what? Sigma is equal to what? Mean minus mode upon what? This coefficient of skewness. Okay. Therefore, what we get? The sigma is equal to what? Mean is how much? 45. Mode is how much? 49. Upon this is minus 0.4. So we get minus 4 upon minus 0.4. So it is what? 10. So we get standard deviation is 10. Once we get standard deviation, we can easily determine this CV. What is CV? CV is what? Standard deviation upon what? Modulus of mean multiplied by what? 100. So, standard deviation is 10 upon this is 45 multiplied by what? 100. So, this one we get 22.22. This much percentage. Now, our aim to determine median. So, for that, again, what is with us? Mean minus mode is equal to 3 times mean minus what? Median by empirical relation. By empirical relation between them. Okay. So, here mean is how much? 45 minus mode is 49 equal to 3 times. What is mean? Again 45 minus median. Okay. So, what does this give? This is minus 4 upon 3 I can write. It is what? 45 minus median. So, we get median is equal to what? 45 plus 4 by 3. So, that simplification will be how much? This is equivalent to median is equal to 139 upon what? This product, and this will be what? Upon 3. So, we get this is how much? 46.33. So, we get median is what? Median is equal to 46.33. This is the answer. And this is what? CV. This is second one you can say by empirical relation. As such, we can easily determine the whatever asked to us. Now, let me take the next one. The next example is for same kind of things are given to us there. So, next one, the mean standard deviation and Pearson's coefficient of skewness of a frequency distribution R what? 58, 20 and minus 0.32. Find mode and median. These are the question. Okay. So now solution. What is given to us? Given things. Let us see them first. We have x bar, that is how much? 58. Okay. Next, standard deviation, that is sigma, is how much? 20. And the next one, Pearson's coefficient of skewness, so SKP. It will be minus 0.32. What we have to find? To find what? Mode and what? Median. These things we have to determine. Okay. So now we know that coefficient of skewness is what? Mean minus mode upon standard deviation. So, from that we get mode equal to what? Mean minus standard deviation multiply what? Coefficient of skewness. So we get 58 minus standard deviation is how much? 20 into this is 0.32, negative of 0.32. Okay. So simplifying, we get this is how much? This will be 64.4. Okay. This is what mode we have been found. Now the question left for median. So median can be easily determined. This is what? Mode. Okay. Median can be easily determined using empirical relation. So also mean minus mode is equivalent to what? 3 times mean minus median. So from that we can easily get that median equal to what? 2 times mean. If we open these brackets, we will get as such 2 times mean plus mode upon 3. Median we will shift to this side, mean mode we will shift to this side. So 3 times mean minus this mean will left 2 times mean, and mode will become positive. As such we get the result. This is by empirical relation. Empirical relation. Okay. Now we have the value of mean. So 2 times what? 58. Mode with us now 64.4 upon 3. So this calculation will be 180.4 upon 3. So this is 60.133. As such we get median. Sorry, here the spelling will be wrong. It is what? Median. Okay. So median is what? 60.133. This much. This is the solution here. As such we can solve the problems to find mean, median, mode and whatever it from the coefficient of skewness. Okay, here we will stop for this one. Next video we will see some more examples on this one. Okay, thank you.